So looking at number 15 from worksheet, whatever number this is, worksheet 5, because it leads into unit 6. So if x minus 5 and x plus 4 are factors of this thing, find all the zeros of that thing. Well, I guess the first question would be, how many zeros are there? So how many am I looking for? How many zeros does this thing have? 4. So I should have 4 answers. I might have some repeated answers, but I've got 4 answers. They basically give me 2 of them, because if x minus 5 is a factor, then x equals 5 is a 0. X plus 4 is a factor, then x equals negative 4 is a 0. So I guess I'm sort of halfway there, because they gave me 2 of the answers. It's the other 2 answers that I'm kind of worried about. Let's divide what they gave us by the zeros that we know will work. Which I guess in some ways seems like, I don't know, why would we do that? We know 5 is a 0. Why am I testing it? The reason is, I know it's going to work, so I know I'm going to get, or at least I should get, 0 for a remainder. But that will give me a sort of reduced set of coefficients to work with. And so that should make my problem a little easier.
Don't we need a 0 because we're missing inputs?
Oh, yes. Wait. I wonder, I just glossed right over that. I wonder if that's supposed to be a 58x. Did this problem last period, and I didn't even see that. I think that's supposed to be a 58x for this to work. Good catch. That would have been cruel to. Well, either way, it's a typo or a bad problem.
Would you be able to do the 4 the first time, or would it still work out?
Yep. So the question was, could we do negative 4 the first time? Yes. Well, your coefficients are going to look different, but after you do both of them, you should be down to the same set of coefficients. So the order doesn't matter to the final answer, but it would matter on this middle step here. All right, copy down the 1, multiply, add. Usually I advocate for going slow and steady and cautious, but when I know the answer is supposed to be 0, I kind of speed up a little bit, and if I hit 0 at the end, I know I did it right. If I don't get 0 at the end, then I better slow down and see what happens. So we get 0 at the end. That's not a surprise. That wasn't really the point of this problem, was to see if 5 worked. We knew it worked. The point of the problem was to go from an x to the 4th to an x cubed. In fact, now we can use those depressed coefficients. That's really what they're called, depressed coefficients, or a depressed polynomial, because the degree went down 1. So, going down, depressed. Copy down the 1, multiply, add, multiply, add, multiply, add. Again, I do that a little faster than normal because I know my answer is supposed to be 0. So I started with an x to the 4th. One successful division got me to x cubed. Successful meaning remainder 0. Another successful synthetic division has me down to an x squared. Oh, this is good news. So I've got 2 answers, and I've got a quadratic, and I can always solve any quadratic. So hopefully it factors, but if it doesn't, I can use quadratic formula. I think this one factors. X equals 2, x equals 1. And so there are, we said at the very first we should have 4 answers, and we've got 4 answers. So we didn't do one quite like that, so I expected that question, but that very much leads into what we'll do today. Plus we got a little synthetic division reminder thrown in there. Unit 2, Day 6, solving polynomial equations. parentheses, kind of like the one we just did. I don't know, the first 3/4 of this, first half, is definitely review, and then there's one small new thing that we'll do. Set polynomial equal to 0 to find zeros. That's why they're called zeros. They make the thing equal 0. So set it equal to 0 if you want to find the zeros, or the roots, or the x-intercepts. We kind of use those interchangeably. They're not perfectly interchangeable, because the imaginary zeros and roots wouldn't actually be x-intercepts, but we still kind of use them interchangeably. And then we said this already on number 15. The degree tells how many zeros. The degree tells you how many zeros. Sort of. What do I mean sort of? What do I have to be careful about there? When does it not exactly tell you how many zeros there are? Or when do we have to be careful? When it's what? Yeah, if there's a double or a triple. So if you have a repeated root, let's just say be careful of repeated roots. So I would still say it has 4 zeros, but you have to be careful if one of them is a double zero or a double root. All right, let's do a couple of review questions. If g of x equals x times 3x plus 2 times x minus 3 squared times 2x plus 7, that would be really ugly, but it's already factored, so they did the hard part for us. I'm going to ask 3 questions. The degree, the number of zeros, and then let's actually find the zeros. I don't think anyone in here would do this, but I think I've maybe said it strangely before, that, or you think in your brain that the degree is the highest power of x, and so some people are like, aha, there's an x squared, that's the highest power of x. Now, that's not what we mean. We mean the highest power of x if we multiplied it all out. So if we multiplied all of that out, what would the power of x be? 5. Like, you don't actually have to do it. Like, there's one there, and there's another one, and there's 2 more. And so, yeah, this would be x to the 5th. In fact, not that this really matters for this problem, but it would be 6x to the 5th. And then after that, it would take a lot of work to find the rest of it, but I don't really need the rest of it. It's degree 5, which means how many zeros are there? 5. So that's always kind of the same question, how many zeros and what's the degree? Now, what are the zeros? Well, that's not bad either, since it's already factored. But some people still mess up that x out front. What does that mean a zero is? 0. And then 3x plus 2, that would lead to negative 2/3. X equals 3, although what's special about x equals 3? That's a double root. And then x equals negative 7/2. And again, I don't have to label that as a double root, but if I'm trying to make sense of the problem, and I said there were 5 zeros, if I don't recognize that that's a double root, maybe it feels like I'm missing something, right? Because there's only 4 zeros there, except that one of them is a double. Example 2. Find a fourth degree polynomial with roots of negative 4i and square root of 5. Combining two examples into one here, but catching both things that I want to make sure we remember. Okay, fourth degree means I should have 4 roots. It only gave me 2, sort of. Sort of, because if negative 4i is a root, what else is a root? Positive 4i, because they always come in pairs. Imaginaries always come in pairs. If square root of 5 is a root, then what else is a root? Negative square root of 5, because irrationals always come in pairs. Okay, so I've got 4 zeros, and I know I want a fourth degree, so I've got everything I need. Let's go x minus 4i and x plus 4i. That would be 2 factors. And then x minus root 5 and x plus root 5. So I've got all 4 factors, but I really want you to multiply it all out. That's the algebra part of this. The order you multiply them out doesn't really matter, but in terms of your final answer, but it very much matters in terms of how difficult this problem is going to be. Like if you want to multiply x plus 4i and x minus root 5, you certainly may, but it would be a lot easier if you paired them off. So I'm going to press pause. You multiply that pair of conjugates, and then multiply that pair of conjugates, and then you'll have to FOIL one more time after that. So this is like 3 FOIL problems all at once. Yes, no, good with that? So that covered a lot of stuff in there. It wasn't a hard problem per se, but we had to know the conjugate pair theorem, that they come in pairs, and then we had to do a lot of foiling and be careful with the foiling. I suppose I should probably also put a f of x equals or y equals on that. All right, last review example, and then we'll do something new, kind of new. How many real zeros does f of x equal x cubed plus 16x have? How many real zeros does f of x equals x cubed plus 16x have? You've got to be careful because the snap answer might be the wrong answer. How many total zeros does it have? 3. Yes, but that wasn't the question. I need to know how many real zeros it has. And so I don't know until I actually find them. So let's factor out an x. That leaves x squared plus 16. So x equals 0. That's one real zero. X squared plus 16 equals 0. Square root both sides of that. Plus or minus 4i. So now what's the answer to the question? How many real zeros does that polynomial have? 1. So be careful. Total zeros? 3. Sure, that's the easy question. But it put kind of a qualifier on the question. How many real zeros does it have? It has 1 real zero. All right, the new thing for today is the possible rational roots It's a long title. Theorem. Possible rational roots theorem. I'm trying to figure out how to say it or write it easier than I already have it written. If a polynomial has integer coefficients so they usually do, but that means no weird coefficients, no square root coefficients, no fraction coefficients. If we have an integer coefficient, or if they're all integer coefficients, then every rational root is, and then here's sort of the punchline of the theorem, plus or minus factors of last coefficient over factors of the first coefficient. Factors of last over factors of first. Factors of last over factors of first. So, factors of the last over factors of the first. As long as you've got a sort of normal polynomial, meaning integer coefficients. So here's sort of why this matters is back in the land before calculators, long, long ago when I was a young boy and we didn't have calculators. We had them when I was in high school, but not. We were just getting graphing calculators when I got to high school. That's how old I am. So now, if you have a polynomial, you can just plug it in the calculator and look on the table or look on the graph and find where the zeros are. But if you didn't have a graphing calculator, you were sort of guessing on what would work. It's like looking back at number 15 that we did a while back. They weren't really even guessing here. They just flat out told you what they were. But if you didn't know what they were, how in the world would you start to answer this problem until somebody figured out that, well, you could guess. You could have a good list of guesses. You're not just randomly guessing anymore. You can guess factors of last over factors of first, and your answers will come from that sort of set of numbers, that pool of possible candidates. So in some ways it doesn't matter so much anymore because you can find them on the calculator, but before calculator, this is how we were stuck finding solutions to problems. If f of x equals 4x to the fourth minus 4x cubed plus 5x squared minus x plus 20, let's find the possible. So we're not actually going to find them. We're going to find the possible rational roots. Then on the next example, we'll actually find the ones that work. But first example is, let's just find the set of numbers that might work. Let's find the possible rational roots. So plus or minus factors of the last term would be factors of 20. So that's a lot of combinations. We probably think of them in pairs, but I want to write them in order. So it's a little bit tricky to write them in order, but think of them in pairs. And by that I mean 1 and 20 go together, but I don't want to write 1, 20, because then all my numbers will be out of order. Although it doesn't really matter. I just want them to be nice and organized. Let's see, 2 and 10 pair up to make 20. 3 doesn't work. 4 works though. 4 and 5. And in fact, since those are right next to each other, we found them all. 4 and 5. So 6 factors of 20 over factors of the first term. A little bit easier. 1 and 4 and then just 2. But that's not quite a final answer yet. Like, I want you to actually list them out. I will allow you to put a plus or minus out front. That way you don't have to write out every single thing. You can just put plus or minus. And then, to me, let's put them all over 1, and then we'll put them all over 2, and then we'll put them all over 4. So over 1 is super easy because that would just be the list. 1, 2, 4, 5, 10, 20. Right? 1 over 1, 2 over 1, 4 over 1. Now let's put them all over 2. So 1 over 2. Be careful, because I don't want you to double list anything. Like, we want a shorter list, not a longer list. So 2 over 2. Do I already have 2 over 2 listed? Yep. 4 over 2? Yep. 5 over 2? No, I don't have that one. So 5 over 2. 10 over 2 is 5, so we got that one. 20 over 2 is 10, so we got that one. So over 2 didn't add a whole lot for us, which is fine. We'd rather it not add a whole lot for us. And then over 4, 1 over 4, 2 over 4 is the same as 1/2. 4 over 4 we have. 5 over 4 we don't have. 10 over 4? Yes, because that's 5/2. 20 over 4 is 5, so that didn't add a whole lot either. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But plus or minus, so that's still 20 possible rational roots. So that's still not really a fun pool to guess from. If we told you to find the roots, you'd have to guess from those 20 to find how many roots are there. How many total zeros are there to this polynomial? 4. So if you were really having a bad day, you could guess 16 wrong answers before you got one. I mean, the odds that you guess the exact 16 wrong ones is pretty low, but that would be a bummer of a day if that happened. All that to say, when we want you to guess, we're not going to give you one that has 20 possible guesses because we don't want you to spend forever spinning your wheels. So let's do one where we want you to find all the roots of x cubed plus 2x squared minus 5x minus 6 equals 0. Okay, so even before we start this problem, let's go big picture here. How many roots are there going to be? 3. So like find all 3 roots. So at least I know how many answers I'm supposed to get. I should have 3 answers to this thing. Yeah, but it won't factor. I don't have a calculator. So I could just start randomly guessing numbers, but that doesn't seem like a good plan. Let's list out the possible rational roots. So plus or minus, factors of the last. I don't really care that it's a -6 because I've got plus or minus already there. So 1 and 6, 2 and 3. And factors of the first, well, that's just 1, so this is a lot easier to deal with. So there's 3 right answers. I've got 8 guesses to pick from, so I guess in theory I could still guess wrong 5 times before hitting one. 1, 3, whoops, 1, 2, negative 5, negative 6. Let's just start with 1 and see if it works. When I say it works, how will I know if it works? What am I looking for? Good, remainder 0. And we have synthetic division, so that goes pretty quick. Although, I don't know that it's 0, so I better slow down here and make sure I don't make any mistakes. Multiply, add, multiply, add, multiply, add. Negative 8. So that's unfortunate. 1 did not work. Well, what would you like to try next? I know, it's like, I don't know. You're probably thinking, why don't you tell us one that you know will work so we don't waste our time? Well, let's try negative 1 and just see what happens. You'll find out if I'm being kind or mean today. So 1, 2, negative 5, negative 6. Copy our coefficients down. Bring down the 1. Multiply, add, multiply, add, multiply, add. Hey, good news. Good news. So x equals negative 1 is one of our answers. Now there are two paths you can take at this point. You can take the hard path, and the hard path would be, well, let's just keep guessing until we find the other two. And you can do that, but a much better choice would be, do you know what the other choice would be? So, well, we kind of plugged in negative 1, but I want to use these answers that we got. So if negative 1 works, meaning x plus 1 is a factor, then I can use these depressed coefficients and use the depressed polynomial. And that's going to be a whole lot easier to work with, because now it's a quadratic and I can always solve a quadratic. So rather than going and guessing plus or minus 2, plus or minus 3, plus or minus 6, and getting frustrated with the whole deal, use the depressed coefficients. X plus 3, x minus 2. So x equals negative 3 and x equals 2. And by the way, we said we wanted 3 answers, and now I've got 3 answers. So all is right with the world. All right, today's assignment's worksheet 6. I do want to look at one of them with you, and that is number 9. Because, well, 7, 8, 9, but we'll do number 9 together, because they're all kind of the same problem. Find all the roots, find all the zeros, solve. That's the same question, just asked different ways. 7 and 8 are kind of like the one we just did. They have 3 zeros. So yes, you have to play the guessing game, but you really only have to find 1, because then you're good. You're down to an x squared. On number 9, you're starting with an x to the 4th. So how many do you have to guess correctly before you have something that you can get it? So yeah, there's 4 total. But once I get it to an x squared, all is right. So how many do I have to guess before I'm good? Yeah, I got to guess 2 right to get it down to something I can handle. So 4 total, but if I can get it down to a quadratic, I'm good. Our PRR, our possible rational roots. If you want to call them zeros, it makes for a more fun abbreviation. PRZ, PERS, possible rational zeros, but same thing. Let's see, factors of last over factors of first, which is just 1. So it's not a terrible number to have to guess from. Right, there's 8. 8 guesses, 4 answers, but I got to find 2 of them. Generally speaking, you should start your guesses low, because that's usually it's not plus and minus 6, or usually it's the low ones. So start with the low ones. I can't guarantee that always works, but start with the low ones. Ooh, sometimes life is very good. So x equals 1. We're good. 1 down, 3 to go. But then use the depressed coefficients. It makes your life easier. Also, you'll never get to a quadratic if you keep going back to the original, right? You'll be stuck at x cubed all the time. So use those depressed coefficients. I know. Very sad. They lost a degree. And, okay, side note here. You don't have to remember this, but after you do a bunch of them, you start to realize things. If I put a positive number out here, and all I do is multiply, add with a bunch of positive numbers, there's no way I'm going to get to 0. Right? If I put a 2 out there and multiply and add, I'm just getting bigger and bigger. I'm never going to land at 0. So I need to try a negative number. I don't know which one, but I need to try a negative number. So let's try negative 1. Dang it, that didn't work, did it? So back to the, not back all the way to the original, but back to the depressed coefficients. Let's try negative 2. Bring down the 1, multiply, add, a lot of zeros. But that worked out. Be careful, like that's all good work, but you haven't really told me that x equals negative 2 is a 0 yet. I mean, I can tell it is, but I need you to say x equals negative 2. That worked. We're good with that one. And then what do I do with this 103 business? What's that? That's a quadratic. So x squared plus 3 equals 0. That won't factor, but I don't need to use the quadratic formula because I can just move the 3 over and use the square root method, the plus or minus square root method. Can't fit them all on the screen, but did I find 4 zeros? Yeah, 2 real ones and 2 imaginary ones. This also illustrates that you would never, you're not guaranteed that all of the answers are real or rational. It's just the nice ones come from the possible rational roots theorem. Like you never would have guessed I root 3. I don't think. All right, so again, the only new thing today is this possible rational roots and guessing, but you're guessing smartly. Tomorrow, it's the same stuff. They're just a little bit harder. So we'll have some x to the 5th thrown in, a few more guesses to have to pick from. It's still the same stuff. It's just a little bit harder.
Typically on tests, how do students score?